Why do ice cubes crack in your drink? Hi, welcome to Curious Kids Every Day. I'm Josh. How are you doing today? It's so good to hear from you. Hey, do you like to put ice in your drinks? I do, especially after I've finished being outside and maybe doing some exercise. Ooh, that cold water always tastes so good. Have you ever noticed that sound that ice sometimes makes when you put it in water? What is that sound? Yeah, it kind of sounds like it cracks. But why does ice, which is just frozen water, why does it crack when it touches water? Well, let's figure it out today. The reason that ice makes that sound is that the frozen water is getting pushed and pulled due to temperature changes. See, temperature changes make materials change size. Did you know that? When something warms up, its tiny particles wiggle more and the material usually expands a little bit. And inversely, when something cools down, particles wiggle less and it usually shrinks a little. This happens even to solid things. It's true. Here's an example you might have seen at your house. Have you ever had a jar that was really hard to get the lid to come off of it? Sometimes grown-ups will run the metal lid under warm water. Do you know why they do that? Well, when the lid warms up, the tiny particles in the metal start moving a little more, and the metal expands just a tiny bit, but hopefully it's enough that it makes it easier to unscrew the lid. Now, ice is also a solid. And the thing about solids is that even when the temperature changes, they don't really like to change sizes quickly, especially when one part warms up faster than another part. Imagine an ice cube that just came from the freezer. Imagine that you're an ice cube, okay? And you just got out of the freezer, so you're feeling really cold. Then you get dunked into some water. Bloop. The outside of you touches the drink first. And that outside warms up quickly because the temperature of that water is a lot warmer than the temperature of you, because you're a piece of ice, remember? So your outside is warming up, but your inside, your core, still very cold. So the outside tries to expand a tiny bit while the inside is still staying the same size. That creates stress, which means a pushing or pulling force inside of a solid. If the stress gets strong enough, a crack can form. Oh, you cracked. And when that crack forms or spreads, you can hear it. Now, another thing about ice is that ice often has tiny trapped air bubbles inside of it. Have you ever looked really closely at a piece of ice? Can you see through a piece of ice? It's just frozen water, right? Well, yeah, you can't really see through ice, even though it's just water. See, those cloudy parts that you see in the ice, you see those because there's lots of little pockets of air and tiny imperfections in the crystal. Those little air bubbles make weak spots inside the ice cube. And when the ice starts warming up in your drink, the cube expands a tiny bit like we were talking about, and those weak spots can shift or stretch. That can help small cracks start, or make cracks that are already there grow bigger. Now, why does cracking happen more sometimes and less other times. What determines that? Well, what you're drinking makes a big difference. Specifically, the temperature of your drink. See, if your drink is much warmer than the ice cube, the outside warms fast and the inside stays cold longer, so the stress difference is bigger. That makes cracking more likely. But if your drink is already very cold, maybe you had a cup of water that was in the refrigerator and you pull it out and you just want it to be even colder, so you put some ice in it. Well, that temperature change is a lot smaller, so cracking is less likely. So when you hear that cracking, it's basically just a solid object trying to expand when it's really hard for it to do so. And sometimes, like when you're an ice cube, all you can do is crack. Okay, let's have a quick quiz. When a solid warms up, it usually does what? It usually expands a little. And if the outside warms faster than the inside, does that make cracking more likely or less likely? Yes, more likely. And what is one thing that can be trapped inside frozen water that helps cracks start? Tiny air bubbles. Let's play true or false. True or false? A bigger temperature difference between the drink and the cube can make cracking more likely. That is true. True or false? Some cloudy spots in frozen water can be caused by tiny pockets of air. That's true too. True or false? If a drink is already very cold, cracking is always guaranteed. That is false. Cracking is less likely when the drink is very cold. Would you rather drink warm drinks for the rest of your life or cold drinks for the rest of your life? When it is very cold outside, it is nice to drink a warm drink, but it is much nicer to drink a cold drink when you're really hot. So I don't think I could go without those cold drinks. I'm going to go with cold drinks. What about you? All right, let's play a round of What Am I? What am I? I can get trapped inside frozen water. I can help start cracks by making weak spots. And I can make frozen water look cloudy or white. What am I? I am tiny air bubbles. All right, I'm going to name something and you tell me, is that thing made of water or not made of water? Are you ready? Is a cloud made of water? Yes, a cloud is made of water. What about steam from a hot pot? That's made of water too. What about a plastic bottle? A plastic bottle might have water inside of it, but the plastic bottle itself is not made of water. What about juice? Is juice made of water? Yep, juice is made of water. What about honey? Is honey made of water? No, it is not. What about a snowflake? Well, a snowflake is made of snow, and snow is made of water. And what about cooking oil? No, that is not made of water. Well, the next time you hear that little crack pop sound in your drink, you'll know what's happening. One part of the cube is warming faster than another part, and that uneven warming creates stress. Then when you add in tiny trapped air bubbles and the crystal structure of a solid, and it's no wonder you hear all that noise. If you want to test it, try listening carefully with different drinks. A colder drink usually makes fewer pops because the temperature change is smaller. A warmer drink often makes more pops because the outside warms faster. And if you look closely when you drop the ice into your drink, you might see the ice cracking too. Isn't it so cool that temperature actually affects the size of things? Pretty amazing. What kind of question do you think we'll ask tomorrow on Curious Kids Every Day? I can't wait to find out, so until then, keep asking questions and stay curious, kids. We've got a few birthdays today. Today is Jay's birthday. Jay is from Washington, and Jay is turning 3. Happy birthday, Jay! Tabor is from Tennessee, and Tabor is turning 7. Happy birthday, Tabor! Reagan's birthday is today too. Reagan is turning 5. Happy birthday, Reagan! Rowan is from Indiana, and Rowan is turning 8. Happy birthday, Rowan! Violet is from Massachusetts, and Violet is turning 4. Happy birthday, Violet! Dashiell is from California, and Dashiell is turning 5. Happy birthday, Dashiell! To all the grown-ups listening, if your curious kid wants their birthday mentioned on the show, please visit supportcuriouskids.com and join the Curious Kids Club. That's supportcuriouskids.com. See you tomorrow!